If you watched the previous video I posted, which you should have on the bus on the way to school, then you'll know that I went over Chapter 7, Sections 7.1 to 7.5 of the Grade 10 Math textbook. And in this video, I'm going to go over Chapter 7, Section 7.6 of the textbook, as well as some questions that are going to be on your test tomorrow. So, for Section 7.6, we're talking about the properties of systems of linear equations. And this section is not so much about solving systems of linear equations or linear systems, but rather on determining how many possible solutions a system of linear equation has. So there's three different possibilities. A system of linear equations can have one solution in which the lines intersect at a single point. So when you would basically take the linear system, you would put each equation into slope-intercept form and graph them, as we did in section 7.2, and if the lines intersect, i.e. cross, at a single point, well, that single point represents a single unique solution. So in which case that linear system would have one solution. And the way we can determine that is we don't actually have to graph it. We can put the equations both in slope-intercept form, and if the slopes are different, then in this case, for example, we have one of the equations is y equals 2x plus 1, and the other equation is y equals negative x plus 1. Well, here we can see that the slope on this equation, when it's in y equals mx plus b form, is 2, and the slope in this equation is negative 1. The 1 is implied. So because those slopes are different, the lines cross at a single point, at one point, therefore having one unique solution. A linear system, or system of linear equations, can also have no solution, in which case the lines are parallel. And how do we tell if lines are parallel? Well, we did this in previous chapters, where if they have the same slope, they're parallel. But in particular, for a linear system to have no solution, the lines need to be parallel, meaning they need to have the same slope, but they need to have a different y-intercept. So for example, if you look at these two equations, we have y equals 3x plus 2 and y equals 3x minus 1. You can see that both equations have 3x, so they both have a 3 for their slope. Therefore, the lines are parallel. But they both have a different y-intercept. So for example, this equation would intercept the y-axis at positive 2, and this one is going to intercept at negative 1. So the lines are parallel, but because they have a different y-intercept, there's going to be no point of insertion. Parallel lines never meet. And because they have different y-intercept, they're not on top of each other. They are different lines. So that's no solution. There's also a possibility for a linear system to have infinitely many solutions. Okay, this occurs when two equations are the same line, meaning every point on the line is a solution. So for example, in this case, we have equations 1 and 2 here, and although they look different at first glance, this is 2x plus 4y equals 8, and this is x plus 2y equals 4, really this equation, equation 1, is just equation 2 multiplied by 2. If I took equation 2 and multiplied all the terms by 2, I'd get 2x plus 4y equals 8. Well, that's exactly what equation 1 is. So basically, if the two equations represent the same line, they have infinitely many solutions. And often this will be the case, you won't see two equations look exactly the same, but one equation will be a scalar multiple of the other, meaning it'll be multiplied by a non-zero number, like positive 4, or 7, or negative 2, or even 1. It could be the same thing. But if one equation is a scalar multiple of the other, meaning if you multiply one equation by a non-zero number and you can get the other equation, then you're dealing with what are called coincident lines, meaning lines on top of each other. The equations represent the same line. So section 7.6 is all about that. It's not about determining what the solution is to a system of linear equations. It's determining how many solutions that system of linear equation has. And again, there are three possible solutions to any system of linear equations. You can have one solution, in which case the slopes are different. So you just put the equations in slope-intercept form. Y equals mx plus b, and if the slopes are different, you're done. You know that there's one unique solution. Because if the slopes are different, that means that the lines are non-parallel, and they'll eventually cross at an intersection and have one unique solution. If you find when you put the equations in slope-intercept form that the slopes are the same, then you still have a little more work to do, because the slopes being the same could indicate that you have no solutions or infinitely many solutions. If the slopes are the same, you have to look at the b-intercept. If the b-intercept is different, the y-intercept represented by b, if the y-intercept is different, then you just have parallel lines, in which case you have no solution. The lines will never cross, they'll never have an intersection point, and you have no solution. If the y-intercept is the same, meaning one equation is just a scalar multiple of the other, meaning they have the same slope and the same y-intercept when they're in their simplest form, when you solve for y equals mx plus b, then you have infinitely many solutions because the lines represent the exact same line. The equations represent the same line. They're coincident lines on top of each other. So the importance of this section, 7.6, was by examining the slopes and y-intercepts of the linear equations, we can quickly identify whether a system has one solution, no solutions, or infinitely many solutions. And knowing the relationship between the slopes helps predict the behavior of the system without needing to find the actual intersection point. So if you recall from section 7.2, one of the issues with graphing was you took the equations, you put them in y equals mx plus b form. That was fairly quick. That was just math and rearranging equations. But then graphing took a lot of time. Plus, graphing didn't yield accurate results a lot of the time. It gave you approximate answers. So the downfall of graphing was it was time consuming and the answers were approximate. However, with section 7.6, you don't actually have to graph. You just take the equations, you put them in slope-intercept form as if you were going to graph. But now you can just look at the slope and y-intercepts and determine a lot about the equations and know something about the behavior. So again, if you look at the slope, and if you have different slopes when you have both equations on y equals mx plus b form, different slopes, you're done. Different slopes indicate one solution, one possible solution to a linear equation, because different slopes indicate that the lines are non-parallel and therefore they will intersect at one unique point. If you see that the slopes are the same, then you have a little more work to do. You have to look at the y-intercept, because if the slopes are the same, the lines are parallel, but that's only if the y-intercepts are different, in which case you have no solution because you have parallel lines and they'll never meet. If you have the same slope and you look and you have the same y-intercept when you have both equations in y equals mx plus b form, then you have infinitely many solutions because you have two equations that represent the same line and they're coincident. They're on top of each other. So that's what section 7.6 was all about. I'm going to go do a couple things. I've got some exercises done up here that I've already taken the time to write out. And then I'm also going to go over your Mathematics 10C revision, which is a prep for your test tomorrow, as well as your review sheet. So let's do that. So if we look at a couple of the answers, one of the questions, question 1, basically says, which graph represents the solution of the linear equation, this one here, negative 3x minus y equals negative 5 4xb. So we're going to do that, and then we're going to come back and explain why. So again, it's asking what graph represents the solution to the linear equation. So the linear equation is negative 3x minus y equals negative 5. That's equation 1. It's always good to mark your equations just to help keep everything neat and ensure you don't make any mistakes. And the second equation is 4x minus y equals 2. That's equation 2. So in order to solve this, we need to actually put both equations in y equals mx plus b form, because we need to ultimately see which graph represents the equation. So we need to see them in y equals mx plus b form so that we can determine what the slope and the intercepts are. So if I put equation 1 in y equals mx plus b form, I'm going to get negative y, and I'm going to move this on this side of the equal sign. So I'm going to get negative y equals positive 3x, because whenever we move something to the other side of an equal sign, we have to flip the sign. So if it's negative here, it's going to be positive over here. The negative 5 never moves, so that stays like that. But again, I'm not solving for negative y. I'm solving for y equals mx plus b, because remember, the general form of the equation is y equals mx plus b. This is the general form. So we're not solving for negative y. So in that case, we need to times both sides of the equation by negative 1. So if I times both sides by negative 1, I'm going to ultimately end up with y, because negative 1 times negative y is going to be y, equals, and I have to distribute this negative 1 to both terms inside the parenthesis. So it's going to be negative 3x plus 5, because the negative times the negative 1 times negative 5 is plus 5. So from here, we can already see a couple things. We can see that we have a slope of negative 3 and an intercept of 5. So now, if we do the same thing to equation 2 and we put that equals in y equals mx plus b form, I'm going to this time take this y and move it to this side of the equal sign. So I'm going to get y on one side of the equal sign, and I'm going to move this 2 over here. And it's going to become negative 2. Y equals 4x minus 2. So if you see what I did, I took this y, moved it to this side of the equal sign, making it positive, and I took this 2 and moved it to this side, making it negative. And even though I've written the y on the left side here, even though I moved it to the right, it doesn't matter what way you write it, as long as you keep the terms on the right side that you with their other terms. So y equals 4x minus 2. In this case, we can now see that we have a slope of 4 in this equation and negative 2 as an intercept. So now, with this information, we need to go back to the graph. So again, remember that we have a slope of negative 3 and a positive 5 is the y-intercept, and a slope of positive 4 and negative 2 is the intercept. So again, if we had a graph, it'd be something like this. Negative y, negative x. We'd have 1, 2, 3, 4, 5. This is obviously not to scale. 6, 7. So this is 5. So right about here is the y-intercept for here. And then we have 1, negative 2, negative 3, negative 4. And then the y-intercept for B, or for equation 2 rather, would be about here. And I'm not going to draw this to scale, but this has a negative 3 slope. So it's going to be going down 3 for about every one it goes over. So this is going to be very rough, but it'd be something like this. And this has a positive 4 slope. So it's going to be moving up 4 for every one it moves over. So it's going to go something like this. But again, this just tells us where the solution is. The solution would be somewhere around here. This is drawn very roughly, but I don't care about the solution. I just care what the graph generally looks like. I know it's going to start at the y-axis at 5 because the y-intercept is this, and it's going to have a negative slope. It's going to go, down 3, drop or fall 3 for every one it moves over on the x-axis, and this is going to start at negative 2, this line, and it's going to move up 4 for every one it moves over. So I just need to look at which one of these somewhat matches that. And we can see that none of these, so option B, C, and D, none of them match because this intercepts at positive 3. Well, none of my answers had to intercept at positive 3. They were positive 5 and negative 2. And this doesn't intercept negative 2. This, again, doesn't work out. This intercepts at 0 at the origin. And this intercepts at positive 5 on the y-axis here with a negative slope. And it looks to be negative 3. Drops 3 for every one it moves over. And this line intercepts at -2 with a slope of 4. It rises 4 for every 1. But again, the big thing to take away is it intercepts at 5 and -2. This is the only option that could exist. So that would be selection A. Next, we're going to skip question 2 because it seems like you've got that one down, so we don't want to waste our time on that. We'll start with, maybe we'll do ones that you haven't done. So this is determine the number of solutions in the system. So we're going to determine that. So let's just erase this. So again, when you're determining the number of solutions in a linear system, again, you don't have to solve the solution. You don't need to know what the solution is. You just need to know how many solutions there are. Is there 1? Is there 0? Or is there infinitely many? So I'm going to take the first one here. And it seems to be, so A is 2x minus 5y equals 23. And that's equation 1. It's always good to, again, label your equations. And then negative 6x plus 15y equals 21. And that's equation 2. So the first step always when you're doing questions relating to how many solutions you have, if the question asks how many solutions there are to this system of linear equations or this linear system, you always need to take your equations and put them in y equals mx plus b form. So again, always put in y equals mx plus b form, the same way you did when you were graphing to solve. But in this case, you're not graphing. You don't actually need to solve the equation, but you do need in that form so that you can determine the number of solutions. So if I take equation 1, this one, and I put it in y equals mx plus b form, I'm going to, let me just do it down here. I'm going to go rewrite it, 2x minus 5y equals 23. So I'm going to move this to this side, leaving the negative 5y by itself, and this is going to become negative 2x on this side, plus the 23 that was still there. I'm going to divide both sides by negative 5, which these cancel out, and we get y equals, and I'm going to just group these together, and then group these together, doing that heart formula. So negative 2x over negative 5, well, the negatives cancel out, and it becomes 2/5 x. And then positive 23 over negative 5, that becomes negative 23 over 5. So not really nice numbers, but that doesn't matter because we're not trying to solve this. We don't need to graph this, so it doesn't matter how nice they work out. All that we need to determine from this is we need to see what the slope is and possibly the intercept, but we'll take a minute to find that out. So that's equation 1. Then for equation 2, if I put that in y equals mx plus b form, I'm going to rewrite it just so we can see what's happening. Equals 21. So I'm going to move this to this side. So it's going to be left with 15y on this side equals positive 6x, because again, whenever I move something to the other side of the equal sign, I have to flip the sign. So it was negative, so now it becomes positive. The 21 was still over there. If I divide both sides by 15, I get y equals 6 over 15 x plus 21 over 15. And we'll just write that again, 6 over 15x, I believe. So 6 over 15x, well, 3 goes into 6 twice, and 3 goes into 15 5 times. So this simplifies to 2/5 x plus 3 goes into 15 5 times, as we just said, and it goes into 21, well, if not 5 times, 6, 7 times. So 15, 3 goes into 21 7 times. So we can see now that we have the slope and the y-intercept, but we don't have to really concern ourselves with the y-intercept, because what do we see? We see that they have the same slope. So actually, we do have to concern ourselves with the y-intercept. I misspoke there. So because they have the same slope, it means that we have to check something further. We have to look at the y-intercept, because if that y-intercept was the same, it would mean that these are the same line, and they'd be on top of each other in the graph, in which case they'd have infinite many solutions. But in this case, because they're not the same, the graph would look something like this. So this is going to intercept at negative 23 over 5, this equation, which roughly is not quite 5. It's 4 and 3/5. So negative 1, 2, 3, 4, 5. So somewhere around here, this is going to intercept, and it's going to have a positive slope of 2/5, which is a little less than half. But so, something like that. That's not at all to scale, but. And then this is going to intercept at 7/5, which is 1 and 2/5. So, somewhere around here it's going to intercept, and it has a positive slope of 2/5. And this was drawn horribly to scale, but essentially these would be parallel. So I'm not an artist by any means, but these would be parallel, meaning they'll never meet. So this has no solution. So because they'll never meet, their parallel lines, there is no solution to this equation. So when you have the same slope as we do in this question, you always have to then look at the y-intercept. If the y-intercepts are different, then you just have parallel lines, because they intersect the y-axis at different spots, but they're never going to cross. You're never going to get an intersection. This line is never going to go there and cross this line, giving us a single point. So they're parallel lines, there's no solution. If the y-axis happened to be the same, well, then they'd be lines just drawn on top of each other. They'd be the same line. So in this particular case, there is no solution. Why? Well, again, because we looked at the slope was the same, and as soon as we see the slope is the same, there's only two possibilities. There's either no solutions or infinitely many solutions. That's determined by the y-intercept. So let's do another question. Just erase this here. So that's one question. Again, the main thing you're looking for in these questions to determine the number of solutions is you're putting both equations in y equals mx plus b form, and then you're determining the slopes. If the slopes are different, then right away you have one unique solution. If the slopes are the same, you have no solutions or infinitely many solutions. That will depend on the y-intercept. You have to look a little further. If the y-intercept's the same, then you have the two equations represent the same line. You have infinitely many solutions. You have coincident lines. If they're different, if the y-intercepts are different, you have just parallel lines and there's no solution. So let's do one more question just to drive that point home. Okay, so the next one says 14x, and feel free to pause the video and after I write the equations down and see if you can get it yourself. So 14x plus 7y equals 315 is one equation, and 17x minus 2y equals 610 is the second equation. And again, if I put both equations in y equals plus b form, I'll be able to determine the slope. So the first equation we're going to do right here, 14x plus 7y equals 315. I'm going to move this to this side, leaving the 7y on the left, and the 14x becomes negative 14x plus 315 because that didn't change. Divide both sides by 7, and we get y equals negative 14 over 7 is negative 2x plus 315 over 7 is some number. We'll take a look in a second because I'm not sure if I need it, and I don't have a calculator. I guess I could pull up a calculator. And then we'll do this one right here. 16x minus 2y equals 610. So we're going to put the negative 2y on this side. It's just going to be easier for me. And I'm going to put the positive 610 on this side. So I'm going to get 16x negative 610, because it's going to come on this side, equals positive 2y. I'm going to divide both sides by 2, and it's going to leave me with y equals, 16 over 2 is 8x, minus 610 over 2 is 305. And this is why I didn't bother taking the time to figure out the y-intercept, because I could have got my calculator figured out, but I didn't need to know, because in this case I can see that the slopes are different. So because the slopes are different, I've got a negative 2 here and a positive 8 there. The slopes are different, so whenever the slopes are different, your solution is one solution. You have one unique solution when the slopes are different. So we'll just do one more question here. See, that's question 6. Just bear with me. We'll do this last one here. So again, just while I'm erasing here, whenever you're doing these questions that you're trying to determine the number of solutions, first thing you do, put your equations in slope-intercept form. Y equals mx plus b. Then when you have them in y equals mx plus b form, you just look at the slope. If the slope is different, right away you have one unique solution, because it means you have non-parallel lines that will intersect somewhere and therefore give you a solution. If the slope is the same, then you have a little more work to do, because you could have no solutions or you could have infinitely many solutions. That's going to depend on the y-intercept. If you have the same y-intercept and the same slope, well, you have the same line and they're on top of each other and you have infinitely many solutions. If you have a different y-intercept but the same slope, you have parallel lines and you have no solution. So here's our two equations again. Equation 1 and equation 2. So for equation 1, I'm going to go 7y equals negative, the 5 is going to go over there and become negative 5x plus 76. Divide everything by 7 to isolate for technical difficulties. Okay. Nope, we might have okay. Okay, well, in this case, I think I'm just going to try to do it this way. So, using the mouse is not going to be very good, but negative 5x divide by 7 and 76 divide by 7. And ultimately, we're going to get, this is going to cancel out, and we're going to be left with y. This looks atrocious. Y equals negative 5 over 7 is the slope. Negative 5, yeah, or s, whatever that is. Negative 5 over 7x. My dexterity is obviously horrible. Plus 76 divided by 7. We know that 7 is a prime number, and it doesn't divide into 76 because it would divide into 70 or 77. So that's just going to get left as is, and because I'm not very good at writing, I'll just rewrite it actually. 76 over 7. That's the y-intercept. Now we're going to write equation 2. So, let me just see here. Quick second. Okay, well, I'm not sure why that's not working, but equation 2, we're kind of going to talk a lot of it through. I'm going to move this negative 3y on this side, become positive 3y. I'm going to take this negative 380 and put it on this side. So ultimately, I'm going to have 35y equals negative 25 because it didn't 25x because it didn't move, and this is just absolutely atrocious. Plus 380. Some of this we'll do in our head. Oh, that looks like 386. It's 380. There you go. That looks worse. But anyway, we're going to divide everything by 35. I'm just going to notionally do it. You know that this would become y. And if I divide this by 35, negative 25 divided by 35 is going to be a negative still. And 5 goes into 25 5 times, and 5 goes into 35 7 times. So we're going to get negative 5 sevenths over x. And if you can kind of already tell, we're starting to see that we have the same slope. So we know that we don't have one unique solution because we'd have to have different slopes, making them non-parallel lines that are going to intersect. But because we have the same slope, we already know we have either 0 or infinite many solutions. So we're going to keep going. I'm going to divide by 35. 380 divided by 35 is going to be 380 divided by 35. If I was to guess, I'm not really sure. 380 divided by 35. 35 times 2 is 70. 70 times 2 is 140. 240 times 2 is, well, more than this. So let's see. 70, 70, and 70 is 210. Plus 70 is 280. Plus 70 is 350. So we're at 350, and it doesn't look like this works out. So unless my numbers are off, this, we'll just see what the answer would be. It says that there's infinitely many solutions, so my math might be off because if I divide this, it might be just, we obviously have the same slope, and if we end up having the same intercept, we're going to have coincident lines, meaning on a graph, this is y, and this is x. If we have coincident lines, it just means the lines are just going to, that was meant to be over there, but okay, that didn't work out at all, but the lines would be on top of each other. Okay, I can't do this. So if the math worked out, which I'll just have to relook, maybe I, oh, that was a negative 35. Negative 35 became positive 35. This came over here, so negative 25x plus 380 divide by 35. Hey Google, what is 380 divided by 35?
The answer is approximately 10.857143.
Hey Google, what is that in a fraction?
Sorry, I don't understand.
Hey Google, what is 380 divided by 35 in a fraction?
Sorry, I didn't understand.
Okay, well, 70. We know that, I'm not going to do it with the math. So Raymond, this video is now went way off the rails. If you have the same slope, then you're going to have either 0 or infinitely many solutions. That's going to depend on the y-intercept. If the y-intercept is different, you have 0 solutions because you just have parallel lines that'll never meet. If you have the same y-intercept, it means you have the same line twice. 2 different equations representing the same line, in which case they'll be right on top of each other, which, again, I can't do with the mouse apparently, but they're coincident lines. So we've derailed quite a bit here, so I do apologize for that. Let's do one other question. You know what? Because I'm having technical difficulties, let's go to the stuff I had pre-done up. So, these are questions I already kind of had looked through the book and found out. So if you go through, these were questions I did up for section 7.1 through 7.6. So these are some exercises associated with 7.1. Again, 7.1, you're just creating a linear system. So they'll either tell you, hey, the question on the test will say create a linear system, or it'll, in in that whole section for the quiz, or it'll just say something in the question, hey, create a linear system, or something along the lines, model the problem of this, which is the same as model the problem is create a linear system, or again, create a system. But in either of those cases, you're basically reading something and you're coming up with two equations. I'm not going to go over that because video is running long. These are questions associated with all the different sections. This is section 7.2, 7.4, 7.5, elimination, and finally 7.6, which is what we'll talk about. If you want to look at this and go through it yourself, a link to this PDF is in the YouTube description. So, Chapter 7, Section 7.6, Properties of Systems of Linear Equations. Again, the whole point of Section 7.6 is not to just solve the system of linear equations, but rather to determine how many possible solutions there are. And there are three distinct solutions to systems of linear equations. You can have one solution, no solutions, or infinitely many solutions. So, to illustrate one solution, consider this equation and this. So this is your system of linear equations. You have y equals 2x plus 1 and y equals negative x plus 3. Because they have different slopes, because we can see this has a slope of 2 and this has a slope of negative 1, because they have different slopes, so when they're graphed, their intersection point provides one unique solution. In this case, 2/5, but that's you don't need to actually graph it and solve it. You just need to know that because there's different slopes, once you put the equations in y equals mx plus b form, you're done. There's different slopes, there's one unique solution. And you've determined that because you'll know the lines will cross because they're non-parallel lines. For no solutions, we take the equations again, put them in y equals mx plus b form, and we see that they have the same slope. So they both have a slope of 3. But they have a different y-intercept. So because they have the same slope, they're parallel lines, but because they have different y-intercepts, they're just parallel lines. They're never going to meet. They're not coincident lines. So again, if they have the same slope, it means they're parallel lines, but because they have different y-intercepts, they're just parallel lines that will never meet. They're not on top of each other. Lastly, for infinite many solutions, you have two linear equations inside of a linear system. So your system of linear equations will have two equations that ultimately boil down in their simplest form to the same line. Both equations represent the same line. So one equation will just be a multiple of the other. So for example, x plus 2y equals 4. Well, if I multiply every term by 2, I'm going to get 2x plus 4y equals 8. So here the second equation is simply a scaled version of the first. Or you can think of the first as a scaled version of this one in the fact that everything's halved, divided by 2 or multiplied by half. Either way, they're scaled versions of each other. So they represent the same line. Thus, at any point on the line, there's a solution. So that's what section 7.6 was all about. So again, all I want you to do on the test is, if it says how many solutions are there, just take the equations, both equations, put them in y equals mx plus b form, slope-intercept form, and look at the slope. If the slope is different, you're done. You can just say there's one unique solution. If the slope is the same, you have a little more work to do. It means you either have no solutions or infinitely many solutions. You have to look at the y-intercept if the slopes are the same. If the y-intercept is different, then you have no solution, because it means you just have parallel lines. You have the same slope but different y-intercepts, so the lines intersect, the y-axis different points. They're just parallel lines. They'll never meet. You have no solution. If you have the same slope but you also have the same y-intercept, it means that both equations represent the same line. They're going to be on top of each other, in which case you have infinitely many solutions. Every point is a solution. And the bus is probably getting to school, so I'll probably start it in the video now. Besides to say, I'm going to quickly go over the whole thing again, but you can stop watching if you want. We've already been through section 7.1 and all that, but I'll do a quick recap. So, in 5 minutes, section 7.1, you're developing systems of linear equations. That's all you're doing. You're reading a real-world scenario, and you're creating a system of linear equations. What is a system of linear equations? It's just two or more linear equations. In Chapter 6, we dealt with linear equations, whereas we read some situation, and we created an equation where we had one unknown variable. For example, if you wanted to know the cost of a rental car, you would, say that, well, it costs $500 base rate plus so much money per kilometer. So you need per distance you traveled, and that would give you your cost. So the unknown was the distance. But if you knew that if you input some distance, you would get the answer. That was a linear equation, one unknown variable. However, a system of linear equations involves two or more linear equations, in your case just two, that each have two unknown variables. You can't solve the equations by themselves in isolation. You can't solve a single equation with two unknown variables. However, because a system of linear equations has two equations, each with two unknown variables, you can solve them together in order to ultimately solve the equation. And when you're creating a system of linear equations, you're just going to have some sentences like this. You're going to have a school bus has the capacity to carry 12 and 24 passengers, total capacity is 780. And there's 20 more small buses than large buses. This little extra bit of information allows you to create two equations that you can use to solve the whole system. Section 7.2 dealt with solving a system of linear equations graphically. Well, that really just involved doing the same thing. You needed to create a system of linear equations in the first place, and then you needed to put each equation in y equals mx plus b form, and then just graph them the way we normally do, using the information, the y-intercept and the slope. And when you graph them, wherever they cross, that intersection point represents the one unique solution to that linear system. So that intersection point is the solution to the system. Yeah, and a lot of times you didn't actually have to create the systems of linear equations. In section 7.2, they gave them to you because you already tested on it in 7.1. So you just had to put each equation in y equals mx plus b form and graph them. Using the graphing calculator, it was just as simple as putting your equations in y equals mx plus b form and plugging them into a calculator and pressing a couple buttons, and it would give you the answer. Section 7.4, that dealt with substitution. Now we're using algebra to solve equations, which is good because solving via graphing is time consuming and it doesn't give you an accurate answer. It gives you an approximate answer. We want an absolute exact answer. So we use substitution. How does this work? Well, we have our two equations and we need to solve one equation for one of the variables in terms of the other variable. So, for example, we might solve it for x in terms of y. And then we're going to substitute that value that we solved for, let's say, x. We're going to substitute that value that we solved for one of the variables into the other equation to find the other variable and actually solve it, with an actual number, with an actual constant, like y equals 7 or something. And then we're able to plug that number back into either the other original equations and solve for the original variable x. And then we've got our solution that we can verify by plugging into the original equations and verifying left side equals right side. There's always going to be one equation typically that is easier to solve. So look for that. And if there's any variables that have a coefficient of 1, meaning they don't have anything in front of them, they just have x or y, solve for that variable. That will be the easier one. When dealing with elimination, you're just going to line up your equations together and make sure they're in the same order, so each equation is in the order of like the x variable, the y variable, the constant. And then you're going to look to see if any of the coefficients match, like if the coefficients on the x variable have the same number, or if the coefficients on the y variable have the same number. If they do, you can either add or subtract the equations together, depending on the sign on the variables, the coefficients, and you can eliminate one of the variables. The whole point of eliminating one of the variables is so now we have equations with just one unknown variable, which we're used to solving. We did that in chapter 6 a lot. And then again, section 7.6 is not about solving systems of linear equations, but rather determining if there's one solution, meaning the slopes are different when you put it in y equals mx plus b form. There's no solutions, meaning the slopes are the same, but the y-intercept's different, or there's infinitely many solutions, meaning you have the same slope and the same y-intercept, i.e. the equations are the same line. Anyway, good luck on your test, and remember, grades don't define us. So if we bomb the test, no one cares, okay? You'll still have your birthday. Life will still move on. So, try your best and, put your effort out there, but, we're not measured by the grades we get. So, good luck, but don't stress.